All right, we're going to be doing 912. We're trading lessons today. Remember, I told you that we are going to skip for a moment, but not forever. We're just trading 911 for 912. We're going to do 912 because I want you to have more experience with completing the square. We're going to do domain of a function. Excuse me. Let's get started.
That's what the whiteboard was for, Seth. I like it.
Oh, yeah.
All right, we're going to review. Get out your whiteboard. On your marks. Get set. Go. I want you to determine if this is a function. Raise your hand if it's a function, yes. Raise your hand if it's a function, no.
That's Ashton's.
That's an Ashton error.
Are you sure? Ashton's incorrect.
Yes.
It's not a function? Which part makes it not a function?
The 5 and 5.
The 5 and the 5. Remember,
Error.
every x must have a unique y. This is not a function, all right? So you are going to be just adding to the function notation today. We're going to add something called a domain. And I'll tell you what that is in a minute. Hopefully my computer won't mess up here. All right. What is the domain of a function? Go ahead and get out your note sheet because that's the first question on your note sheet. And here is the definition of the domain. Write it down and we're going to talk about it. On your marks, get set, go. Number 1 on your note sheet. The domain is a set of all possible inputs or x values. The domain is the set of all possible inputs or all possible x values. It's not difficult. It's just what are the inputs. So in this ordered pair, the domain, you would write it like this. Do not do anything, just watch. The domain looks like this. We usually put a brace, and then we write the x values, -6, -4, 1, and 5. And we only write it one time, and we have finished. Are you looking at me up here?
Yes.
The domain is all of the x values. -6, -4, 1, and 5, and we only list 5 one time. And we're done with the domain. Let's do some on your worksheet. I'm going to let you get started while I set this up. It's on your note sheets. There's going to be a little bit more than that in a little bit, but for right now, that's what it is. Go ahead and write those down. All right, so you're supposed to decide if the relation is a function, and you're supposed to specify the domain.
On the charts.
So here we go. The domain, you should write the word either domain or D equals with a brace. First x value is -4. My next one's -1. My next one is 0. My next one is 4 and 5. Did I have any repeats for the domain?
No.
No. So what does that tell you about this relation?
It's a function.
It is a function. It was a function, and the domain, there was no repeats in the domain, so it was a function. Let's move on to the next one.
Basic get working.
Number 3.
Just say Elijah has
The domain, gentlemen, notice how I'm writing the domain. It's not a little parentheses. It is a D equals with a brace. And my braces didn't look very good on that one. There we go. I have a -4 and I have a listing of a -4 2 times. What does that tell you about this function? Excuse me, this relation.
You only have to write it once.
You only have to write it once. And what, is it a function? No. If it's listed 2 times, it is not a function. And I only have to list it one time. That is correct. So I have a -4. I'd only list it once. I have a -2, a 0, and 1 again, twice. And so we only have to list it once. And since there were repeats on those x values, we knew it was not a function. What are these? And what's this D stand for again?
Where did the 0 come from?
I don't know.
17.
You gotta take some of mine off or point that out.
No.
So nervous about making mistakes because he's keeping tallies. All right, here we go.
Look.
Did I get it right now?
I don't know. We all have to question it all the time at this point.
Yeah, just question me. Question me. You should.
I think that's right now.
Okay.
Yeah, that's correct now.
Or this is different now.
Drive
This
Yeah, how do we
is
do it?
different now. How in the world do we do this one? First of all, you know how to determine if it's a function. Is it a function?
Yeah.
Yes, it's a function because of what test? What test do we do on this
Line
one?
test.
Yes. The which kind of line?
The up and down.
What's the up and down?
Vertical.
Yep.
The vertical line test says that yes, it's a function.
Oh.
Okay. What do these little arrows over here mean?
It keeps going on and on.
It keeps going on and on and on forever and ever. Okay. So all of these x values are going to be represented forever and ever and ever. Ever and ever and ever. How do we say that we're going to do forever and ever and ever? Gentlemen, what kind of numbers are all those? Do you know? Those are called all real numbers. The domain is all real numbers.
Okay. Yes. Yes.
Do you want to learn this symbol for the words all real numbers instead of having to write all those letters?
Yes.
Yes.
Are you ready? I'm not going to show it as pretty. I'll actually text it to your parents later. But it's an R, a capital R, that's got this extra little fancy thing right there. Okay? So
Can we just write R?
you can write R, but make it a little extra thick there, like that. Okay? That is the symbol for all real numbers. Okay?
So what about? We'll get to it.
All right? Let's do another one in a minute. Yes.
Five.
We're going to get to the next one. Okay. Number 5. Number 5. Okay. Is this a function? Yes or no? It's a function.
Yes. So is it? Could you do like R or never mind. I'm just trying to figure out
What numbers does it start with?
all 4.
4 and go backwards, right?
So is it like all real numbers behind 4 or 4 and behind?
Or like
We
less
say it
than
like
4?
this. We say that x goes backwards. So does it include 4? Is 4 one of the numbers that it does include?
Yes.
So it's less than or equal to 4.
Oh, okay.
Okay? All right. And why did I put the equal with a little line under? How do I know it does equal 4?
Because it has the dot.
Because it has the dot. Gentlemen, if it would have had an open circle, it would not have been. And they actually do it that way on purpose. Okay?
So never mind.
Okay? The domain, and we need to put the little brackets like before. Okay? All right, let's do number 6. Number 6, okay, this one. Is this a function, yes or no?
Yes.
Yes, it is. Okay, so function is yes. Okay, but the domain,
Algebra ghost.
is the domain all real numbers? Does it keep going forever and ever? Does it keep going forever and ever?
That's a
No,
mistake
it
for.
doesn't.
That's a mistake for Elijah. Yeah, right. Asa,
Well, this doesn't have, Ben, this doesn't have arrows.
It is not. It's dot.
is it like? Is it -6 is less than or greater than x, and x is less than or greater than 6? Yeah, like that.
Like that. Let's make sure. This says, let's make sure this is this says that x is bigger than -6. Is that what that is? It's bigger than -6, right? But it's also smaller than 6. That is exactly right, JD. Good job.
I did it.
All right. All right, let's go to another one.
Oh, that bottom looks pretty funny.
All right, 7. First of all, is this a function?
Yes.
No.
Yes, it is. That's a mistake for Zach.
Is that a yes?
Yes.
Now, gentlemen,
Asa,
as we're doing this,
Not say that.
when I ask you a question and you get it wrong, it's not really a mistake. It's if they write it down wrong that's a mistake.
Mistake.
So I want you to feel free to not get judged
But he
if
wrote
you
it
make a
down.
mistake.
I wrote
Right?
this.
Okay, so it's a function. Now we got to do the domain. The domain. What's the x value that goes with this one? Gentlemen, what's the x value that goes with that one that I'm circled?
-6.
All right, so that's -6. What's the x value
5.
that goes with the rest of them? This one
5.
and this one is a. Careful, it's not 5.
Oh.
Oh, that one's 5. Yes, it is. I'm going backwards.
That's the
Next.
mistake. Doing
I'm going in
exactly
-3
the
next.
That's
-2 next. And then JD was right about the number 5.
Another mistake. JD was right.
Every
All right, listen. I want you to look at this really quick. The domain, we now are going to go into something a little more complicated. And I want you to write down something in words on your paper.
Like what?
As far as the domain is concerned, for
Write
domain, I want you to write this down. As far as the domain is concerned, no negatives under the square root. Are you with me? I want that to, as far as we talk about what the domain is concerned, there is no negatives under the square root. On your marks, get set, write that down on number 9. As far as we're concerned with the domain, we're talking about real numbers. Eventually, we're going to get into something where we'll have negatives with square roots, but not right now. There are no negatives under the square root. So, if we cannot have any negatives under the square root, that means that the under the square root, that right there, that x plus 3 has to be greater than or equal to 0. Are you with me so far? Anything that's greater than or equal to 0 is not a negative. How do I solve that for x?
-3.
Yes, subtract 3 from both sides.
X is
So the domain is x greater than or equal to -3.
Oh, that's even.
When you have a square root, as far as the domain is concerned, you cannot have negatives under the square root. So we will take what's out of the square root and we'll say that it must be greater than or equal to 0. And then we'll solve for
You
x.
have to put it in those weird brackets.
Yes, please put all your domains in those weird brackets.
It's not a bracket, it's a brace.
There's weird braces. That's right. That's right. It is. Oh! Here we go. Number 10. Which part of that must be greater than or equal to 0? What part of that must be greater than or equal to 0? The 3, the x, or both?
I say we just skip it and move on.
Which one?
Let's answer this question.
Look, what did you write down? It said, as far as the domain
No
concerned,
negatives
under the square root. What's under the square root? The 3, the x, or both?
X.
Just the x. I only need to put the x
my
part
goodness.
greater than or equal to 0, and that is the domain. There's no more to solve. And yes, you have to put the little crazy braces around it.
Whoa.
Here, call it braces too.
I did this time.
Oh, we have one.
It's braces, not brackets.
Oh,
Okay.
it's-
All right. Brackets look like this one. All
Elijah.
I called it
right.
braces.
It's okay.
You called it a
I know braces go on our teeth, but all right. Let's do number 11. All right. I need you to write this down. As far as we talk about with fractions, as far as the domain is concerned, write this down. The domain for things with fractions, there's no 0. Let's do it this way. The denominator cannot equal 0. Cannot equal, I'm going to put that's a little cannot equal. That is a true symbol. It's a does not equal. The denominator cannot equal 0. We've already found excluded values. You've been doing this before. So it's the same as the excluded values. So for the domain, p minus 9 cannot equal 0.
Which means that P can be
Add 9 to the other side, correct?
P cannot equal 9.
P cannot equal 9. That is the domain. Put the little crazy braces on it.
That's easy. So like for this one, K cannot equal 1 for the next.
Let's do the next one and find out. This is number 12, correct? Are we ready to move to 12? Have we written everything down for 11? I don't want to go too fast. All right. It's a fraction, correct? What cannot happen with a fraction?
Have a 0 as the denominator.
Okay, so that means that K plus 1 cannot equal 0, correct?
Yes.
So what is K?
K cannot equal -1.
K cannot equal -1 is the domain. With the crazy braces. All right, everyone, we have learned how to determine the domain. This is a new thing today.
Awesome.
There are multiple things for the domains, but it is the value of the x. It's the x values in an equation, the possible x values. We're now finished. Woo.